5.3, we're looking at right triangles and looking at trig function values based on a right triangle. Start with a right triangle like we have to the left there. The side across from the right angle is the hypotenuse, so the longest side, the hypotenuse. And then we label one of the acute angles with that Greek letter theta. And then the other two sides we're going to label relative to that angle theta. So for the side that is opposite theta, we call it opposite. And for the side that is adjacent or next to theta, we call that adjacent. Okay, now getting to how we define trig function values, it is going to be based on the ratio of the lengths of any pair of sides in the right triangle. All it depends on is the measure of that acute angle theta. Okay, so these ratios are the trig functions. And I've listed out the names of the trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. Usually we use the abbreviations, so sine is abbreviated SIN, and the sine of theta, so if we think of that sine being a function, we're plugging in that angle theta, and to evaluate it, it is the opposite side length over the hypotenuse length. The cosine is the adjacent length over the hypotenuse. The tangent is the opposite side length over the adjacent side length. Now the other three trig function values are the reciprocal values. So we can think of that as how we think of reciprocal in other settings. We're just going to flip the ratios that we have for the main three trig functions. So cosecant, CSC, is hypotenuse over opposite side. The secant is the reciprocal trig function for cosine, so it is hypotenuse over adjacent. And cotangent is the reciprocal trig function for tangent, so it is adjacent over opposite. Another way that we could write those reciprocal trig functions is just literally take the reciprocal of the trig function. So cosecant would be 1 over sine theta. Secant is 1 over cosine theta. And cotangent is 1 over tangent theta. Okay, let's find the trig function values for this particular angle theta in this right triangle. So I have labeled two of the sides. The side that's not labeled is the hypotenuse. And relative to theta, the other two sides that I have labeled are the opposite side, and that has length of 8, and the adjacent side, the side next to that angle theta, that's labeled, and that has a length of 6. All right, so we can use those to evaluate the trig functions. For sine, okay, remember that is opposite over hypotenuse. And we can plug in the opposite side, right? We have that is 8, but we don't know the hypotenuse. Right, we have a tool though in our toolbox that allows us to calculate what that hypotenuse is. So this is Pythagorean theorem. So the hypotenuse equals the opposite side squared, or I'm sorry, hypotenuse squared equals opposite side squared plus adjacent side squared. So if we plug in those two things that we know, opposite side squared is going to be 8 squared, adjacent side squared is 6 squared. So the hypotenuse squared is equal to 64 plus 36. If you take the square root of both sides, hypotenuse is equal to the square root of, well, 64 plus 36 is 100. That is, square root of 100 is 10. All right, so we can add that. We know now the hypotenuse is equal to 10. And we can finish calculating our our ratio 8/10. And reducing that, we get the sine value is 4/5. All right, a cosecant is just going to be the reciprocal of that. So once we find the sine, we just take the reciprocal to get the cosecant. All right, cosine. This is where we're going to take the adjacent side length over the hypotenuse. We know the adjacent side is 6. We already found the hypotenuse. It's 10. Plug that in. Reduce, and we get 3/5. The secant is the reciprocal of cosine, so it is going to be 5/3. Tangent, opposite over adjacent. Right, so we take 8/6 reduces to 4/3. And cotangent is the reciprocal, so that gives us 3/4. All right, so given the value of the trig function for theta, find the values of the other trig functions. And we are assuming that theta is in between 0 and 90. That's just another way of saying that we are assuming that theta is acute. And we can also set up a right triangle and label what we know. So here's our right angle. The opposite side is the hypotenuse. If we label this as theta, okay, we look at what we're given, cosine equal to 2/5. Well, we know that cosine is adjacent over hypotenuse. Okay, so we know that then the hypotenuse is 5. We can label the hypotenuse 5. And we know that the adjacent side is 2. So what we don't know is the opposite side. All right, but again, we can use Pythagorean theorem to find the opposite side. Right? We know that the hypotenuse squared equals adjacent squared plus opposite squared. So we plug in what we know. We know that the hypotenuse is 5, so we have 5 squared equals the adjacent squared, so that's 2 squared, plus, well, we don't know, the opposite squared. So the opposite side is going to be the square root of 5 squared, which is 25, minus 2 squared, which is 4, so we get the square root of 21. So we can fill in that opposite side, square root 21. Now that's all we need to calculate these trig function values, is just the sides of the right triangle. All right, so the sine is opposite over hypotenuse, so that's going to be that square root of 21 that we just found over the hypotenuse of 5. Cosecant is the reciprocal, 5 over square root 21. Cosine was given to us, so we don't need to calculate that. If we want to calculate the secant, though, that's the reciprocal, and that's going to be 5/2. The tangent, opposite over adjacent, so that's square root 21 over the adjacent side of 2, and then the cotangent is the reciprocal, 2 over square root 21. All right, here's another one of these. Cotangent is given to us as 1/3. So we're starting off with a right triangle. And we're given that cotangent is 1/3. Well, cotangent is adjacent over opposite. So what we can fill in here is that, well, first of all, let's label an angle theta. Let's call this one theta, and we could choose the other one. It doesn't matter as long as we label the sides relative to the angle that we choose for theta. All right, so the adjacent side, we're given that that is equal to 1. and the opposite side is 3. So what we don't know is the hypotenuse. All right, so we go and do our calculation for the hypotenuse. So we're going to get that hypotenuse is equal to the square root of the opposite squared, 3 squared, plus the adjacent squared. So that's equal to the square root of 9 plus 1, so the square root of 10. So we can fill that in. The hypotenuse is equal to the square root of 10. Now we can fill out our trig function values. So the sine is opposite over hypotenuse. Cosecant is that reciprocal. Cosine is adjacent over hypotenuse. Secant is the reciprocal, square root 10 over 1, or just square root 10. Tangent is opposite over adjacent, so 3 over 1, or just 3. All right, one more like this. Let's put in our right triangle. And we are given that this sine is 12 over 13. So that's the opposite over the hypotenuse. So we can fill in those two sides. The opposite, well, first of all, let's put our theta here this time. So our opposite theta is 12 and our hypotenuse is 13. So we are looking to fill in the adjacent side. All right, so using the Pythagorean theorem, the adjacent side is going to be equal to the square root of the hypotenuse squared minus the opposite squared. So square root of 13 squared minus 12 squared, which is the square root of 169 minus 144, which is the square root of 25. Square root of 25 is 5. So we can fill in that adjacent side that was unknown with a 5. So now we've got the sides of the right triangle. We can calculate the trig function values. Cosine or cosecant, we're just going to take the reciprocal of what we were given, so 13 over 12. Cosine, adjacent over hypotenuse, so 5 over 13. Secant is the reciprocal. Tangent, opposite, 12 over adjacent of 5, and cotangent, the reciprocal, 5 over 12. In these next examples, we are actually given a angle measure for theta, which we haven't had before. All we've needed is sides of the triangle to evaluate the trig functions. So here we're given a right triangle. Theta, one of the acute angles has measure of 50 degrees. The opposite side has length of 10, and we want to find the length of the adjacent side. So let's draw a picture to get an idea of what our triangle looks like. So there's our right triangle, and let's label this as theta, and we know that that is 50 degrees. The other piece of information we're given is that the opposite side has length of 10. What we want is the adjacent side. All right, we can use the fact that the tangent of an angle theta is equal to the ratio of the opposite over the adjacent side. So let's fill in what we know for this problem in that relationship. Well, we know theta, so we can write in tangent 50 degrees is equal to the opposite, which we were given as 10, over the adjacent. We are going to use our calculator. We're going to plug in tangent of 50 degrees into our calculator. Tangent of 50 is 1.1917, and then it doesn't terminate or repeat, but we know that that's equal to 10 over the adjacent side. Doing a little bit of algebra here, we think about multiplying both sides by this unknown adjacent side. Then we get that the adjacent side is going to be equal to 10 divided by that tangent value that we found. And that equals approximately 8.391. Let's look at another example like this where theta is 15 degrees, hypotenuse is 12 degrees, and we want to know what the adjacent side length is. Drawing our picture, here we've got 15 degrees, and we know the hypotenuse is 12. We want to know this side. All right, this time the ratio that we want to use has to do with the hypotenuse and the adjacent side. Well, that's going to be the cosine. We know that cosine of theta is equal to adjacent over hypotenuse. All right, so plugging those things in that we know, we're going to take cosine of 15 degrees equal to that thing we don't know, the adjacent side, over what we do know, the hypotenuse. Plugging cosine 15 into the calculator gives us a value of 0.9659, and it doesn't repeat, doesn't terminate, and that's equal to adjacent over 12. All right, we just need to multiply both sides by 12 to get the adjacent by itself. So the adjacent equals 12 times 0.9659, or 11.591.